So you remember that flowchart on factoring that started with take the greatest common factor out first and then count the number of terms next. And we had done something with two terms that was the difference of squares. We're now going to do something with two terms, a cubed plus b cubed and a cubed minus b cubed, that's called the sum and difference of cubes. So see the threes here? Now they just have to be multiples of 3, so they can be a 3, a 6, a 9, a 12 to be a sum and difference of cubes. So we're still over here under this flowchart under two terms, but as two terms go, we had the difference of squares, and now we have the sum and difference of cubes. So just going to focus on this for just a little bit now. So finishing up the topic of factoring. So I'm going to have to erase this flowchart. So the sum and difference of cubes is something that is a value raised to the third power plus another value raised to the third power, or minus. And it successfully factors into this format that is a formula. So see this x cubed plus 64? I'm going to have you think of this as x to the third plus 4 to the third. Because 4 to the third means 4 times 4 times 4, and 4 times 4 is 16, and times 4 again is 64. So I'm going to successfully turn this 64 into something cubed. So I'm not going to go there quite yet, so it's going to be x cubed plus 4 cubed is what that's going to be. But if I took this memorized formula, a plus b times a squared, I get a to the third power, and a times a minus ab is a minus a squared b, and a times b squared is a times b squared, but then multiply b times a squared, and that's positive, and that's called b times a squared, so I can write it in this order because multiplication can be done in any order. And then right here, this positive times this negative is a negative a b squared, a negative a b squared. And finally, b times b squared is b cubed. And when I combine my like terms, this negative a squared and this positive b squared cancel out. And this positive ab squared cancels out with that negative ab squared. And all I'm left with here then is a cubed plus b cubed. Likewise, I could multiply this binomial times this trinomial and I'd get this. So what I'm going to do is I'm going to write these statements that are, in this case, the sum of two perfect cubes, and I'm going to figure out what a and b are and plug them into this formula. Would you notice, please, that each of these formulas, the binomial is a and b, and would you notice that this one's the sum of cubes and this sign matches? This one's the difference of cubes and this sign matches. Would you notice that the trinomials are both a squareds, they're both ab's, and they're both b squareds? But would you notice that of this trinomial, would you notice that both of these are positives? But see this minus sign? That's the opposite of the sum of cubes. So when you're doing the sum of cubes, this sign will be a minus. And when you're doing the difference of cubes, this sign will be a positive. So these signs right here match the given problem. So the minus sign matches the minus sign. The plus sign matches the plus sign. These signs right here are opposite the given problem. This one's a minus, this one's a plus. This one's a plus, this one's a minus. And the third sign in the trinomial is always positive. I ask you to think MOP, M-O-P, match, opposite, positive. Finally, in this x cubed plus 64, what I have to think of is I have to think of the letter x gets cubed and the number 4 gets cubed to give me 64. Therefore, I'm going to plug in for a in that formula the letter x because a is cubed. X is cubed. So a is the letter x. In this problem, b is the number 4, because 4 is what it is cubed. So anywhere I see a and b here, I'm going to plug in an x and a 4 into this memorized formula, a plus b times a squared minus ab plus b squared. So I'm going to plug in an x and then a 4 for b, an x again for a, and then an x times a 4 for a and b, plus a b value, which is 4, squared. And I'm going to clean up this trinomial and call it x squared. This x times 4, I'm going to write it as minus 4 times x. 4 squared, I'm going to call 16. And if you wanted to check this binomial times this trinomial by going this times this, and here, and here, and here, and here, and here, you would end up with x cubed plus 64. This is my solution to this problem. I have successfully factored x cubed plus 64 into this binomial times this trinomial. Let's do it again. So over here, again, I'm going to keep them relatively simple. X is the variable that is cubed, and the number 3 is the number that is cubed in order to get 27. You could hit the math key on your calculator, and under that math key is a cubed root symbol. I think it's maybe the 4th item down, and if you selected that and put a 27, it would tell you that the cubed root of 27 is 3. I'm sorry, I forgot to open my calculator before I started. So I have to, in this problem, put in for a, the letter x, put in for b, the number 3, not a negative 3, just the number 3, everywhere I see a and b in this formula, because this one's the difference of cubes. So I'll have x minus 3, and then I'll use these plus signs right here. So I think I can scroll up a little bit. I'm just going to go ahead and let you see the formula again. So it's a minus b times a squared plus ab. That sign is opposite of this. Match, opposite, and always positive right here. So I'm going to put in for a and x, for b a 3, but I got to keep this sign. Then for a and x, and then if you don't mind, a times b is 3 times x. And finally, this last term is 3 squared, and 3 squared is the number 9, so I'm just going to erase that, and I am done. I have factored this. Let's go ahead and do the next one before we stop. Actually, we'll try to get all 4 of these done. So the x cubed term does not need to be first. This is still the difference of 2 perfect cubes. So if you found the cubed root of 64 on your calculator, you would find that is equal to 4, because 4 times 4 times 4 is 64. See the 125? If you found the cubed root of 125 on your calculator, you would get 5, because 5 times 5 is 25 times another 5 is 125. So 5 is the cube root of 125. So I'm needing to take the number 4 and cube it to get 64. And the number 5 and the letter x and cube that. So in other words, 5x times 5x times 5x will give you 125x cubed, which is this term right here. So now I'm going to plug in for a in the memorized formula the number 4, and for b I'm going to plug in the 5x, and it's composed of a binomial times a trinomial. And the binomial is my a value minus my b value. Then my a value squared. Over here I have a minus sign, so this one should be opposite. It's my a value, a times b. That'll be 20x in a minute. And be very, very careful. This last one is your b value squared, the 5x times 5x. So this trinomial will become a 16. 4 squared is 16, plus 20x. And again, 5x squared, this is where people make their mistake. 5x squared means 5x times 5x, and that is 25x squared. Again, with the 4 minus the 5x in the binomial. Some people like to rewrite this trinomial in descending order. So some people like to put the 25x squared first, then the 20x, then the 16. And even up here, you could write the minus 5x first and then the positive 4 if you'd like, or leave it as 4 minus 5x. As long as this 4 had a plus sign, this 5x had a minus sign, so it doesn't matter. Or again, this could have been 4 minus 5x. Let's go to this last one. So let's go to a cubed plus 1/8. And for the time being, I'm going to erase a little bit of this because you caught this from previously in the video. So the letter A is the letter that is cubed in order to get a cubed, capital A cubed. So 1/8, how do you write that as a fraction to the third power? Well, what you do is you say to yourself, what's the cubed root of 1 separately? And what's the cubed root of 8 separately? Well, the cubed root of 1 is 1, because 1 times 1 times 1 is 1. And the cubed root of 8 is 2, because 2 times 2 times 2 is 8. So the fraction 1/2 times 1/2 times 1/2 would give you 1/8. So now I just have to put the a and the 1/2 into the first binomial. Then the a value squared as the first term. This sign has to be opposite the plus sign. It's the a times the b. It's the 1/2 times the a. And finally, this sign is always positive. In this case, it's the 1/2, which is squared. And 1/2 times 1/2, I'm talking about this last term right here, 1/2 times 1/2 is 1/4, and then I'll bring down this first binomial, and if you multiplied this all out, close that up there, you would get a cubed plus 1/8. So I am trying to take you through some college level factoring problems. So we're going to continue with this sum and difference of cubes in the next segment. Quite challenging, the problems I'm going to present. Get a handle on these first. I will also tell you at this time that there are no riddles that I've given you that help you practice to the sum and difference of cubes. But you are now ready to finish the riddles through the last page, except we have not studied the topic that is page 102 of the riddles, which is what is the title of this picture. So don't bother with that one. We'll come back here in a minute to study some more factoring of cubes.